stuff, financial math, you will start off with a recall of some prior information that we already learned, and that is this formula right here. Okay, so this y equals a 1 plus r over n to the nx, compounding interest. Okay, so $1,000 in an account, 3% interest, compounded monthly. That's 12 times per year. How much would you have after 1 year? So we know how to do this already, I think. So y equals, and then so we have 1,000, and then 1 plus r over n. So r was 0.03 over n, which is 12 because you're compounding monthly. 12 times x is 1 because it's only 1 year. And then you would just throw that in the calculator, right? Well, we could get the we can get this first. 1.0304. There was some other decimals here to the 12th, and then that comes out to be $1,030.42. Okay, so that's when this situation and this formula here is used when you just invest money at an interest rate, and then you want to know how much it's worth after a certain amount of time. So we're putting 1,000 in, and we're not adding anything else to it. A structured savings plan is done a little bit differently, and they kind of talk about it here. An annuity, it's called an annuity. An annuity is a series of payments made at fixed intervals of time. Examples of annuities include structured savings plans, lease payments on a car, loan payments, monthly home mortgage payments. You buy a house, you got to make payments. That's how they calculate how much am I going to have to pay per month. How much you buy a new car, how much am I going to have to pay per month for the car. This is how it's calculated. So very, very practical uses here. The term annuity sounds like it is only a yearly payment, but actually annuities are often monthly, quarterly, semi-annually. The future amount of annuity is denoted by A sub F. A sub F. So you'll see that right here, A sub F. And it's the sum of all the individual payments made plus the interest generated. So exercise 1 is not really, we're not going to be doing it like exercise 1, but exercise 1 is just going to show us how the interest is calculated. Interest meaning like, well, this is for savings, so yeah, you're earning interest, not paying interest, earning interest. All right, so this is what happens in exercise 1. $100 deposit is made at the end of every 12 months. At the end of every month for 12 months. So $100 is deposited in January. Now in the recall, the first thing we just did there, $1,000 was put in and that was it. $1,000 done, right? We're not adding every month. Now we're adding money every month. So 100 is put in at the end of January, 100 is put in at the end of February, 100 at the end of March, so on and so forth. So what's going to happen is the sooner the money is put in, the sooner it starts earning interest, if you think about that. So there's this rate, and the rate's not that big of a deal right now. We're not really talking too much about the rate, but that rate of 3%, whatever you put in, that $100 is in there in January, or well, it's in there and starting in February. It's the end of January, right? So starting in February, that $100 is earning interest, right? Now at the end of February, you put in another $200 or another $100. Now you have $200 earning interest. Then at the end of March, you put in another $100. Now $300 is earning interest. So because you keep putting it in, you're going to keep earning interest, but that original 100 is going to earn the most interest. Then the next month, that next 100 is going to earn the next most interest. This right here, this table, is going to figure out how much is the value of each one. All right, so I did this, and I don't want to waste a lot of time doing this. So obviously it would be 100, and I want you to fill this in after the video because I don't want to take too much video time doing this. You could kind of see the pattern, right? To the 8th. Okay, and then it's 102. That comes out to be 102.02. And then the next one's 101.76, 101.51, Okay, 101, $100.75. $100, that's $100.50. $100.25. Oh, I messed up along the way. I messed up somewhere. This should have been 100, 125. This is all off. I don't know what happened. 102.02, 101.76, 101.51, 101. I'm missing a month somewhere. Anyways, 75, 50, 25. I don't know. It doesn't really matter. The point is, you add these up. Instead of adding all of these up, we're going to have a formula that's going to add all this up for us. Okay, and that's basically what we're doing. So the amount for each month added up for us is going to be done in the next formula. So that's basically the point. But anyways, if you add all these up, it does end up coming out to be, if you add all those up, it comes out to be $1,216.63. Now, the important part about this number is you actually put in $1,200 of that yourself. $100 each month, right? 12 months, $100 a month. So $1,200 is what was actually put in yourself. What's the other $16.63? That's the total interest that was earned. See, $278 was earned in January, $253 was earned for the money put in February, $227 was earned for the money put in March. A little bit less each time because you're putting the money in later in the year, so you're not earning as much as the year goes along. The original $100 is still earning, but not that second $100 that's and that third $100 and that fourth $100 that was put in. Those are earning less interest. Total interest was $16.63. That was the interest earned. That was the interest earned. Okay, so that gives us our total of $1,216.63. So that's basically what's going to be happening in this lesson. So here's our formula, and again, this will be given to you. You won't have to memorize it. AF is the future value of deposits and earned interest. R is the recurring payment, that's the monthly payment. I is the interest rate per payment period, and N is the total number of payment periods. So we're going to go through and use this example to do example 1. Okay, so there it is. Now, switch to my page 2 because I have this worked out. I don't want to keep you too long. All right, so AF is going to equal, again, we're just using from our exercise we just did, the recurring payment, which is 100 times 1 plus I. Now in this case, I is the rate 0.0025, and that comes from, that's given to us right here, 0.0025. That came from the rate of 3% divided by the total number of periods. So that came out to be 0.0025. And that's raised to the N. N is 12 because there's 12 payments, divided by, minus 1, and then divided by I, which is 0.0025. Okay, so we're just plugging in this formula, and this could be done in the calculator, and it's going to come out to be $1,216.64. And we got 63 cents when we added the ones in the front, but that's just because of rounding. It's just off by a penny. But this, again, this formula added all the months up for us without having to do, 100, 2 plus 100, 2, blah, 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 just adding those up. This does it for us, okay? Now, in example 2, okay, let's go down there. The interest earned in the future value of annuity with weekly payments. This is weekly payments now. So weekly payments, 52 weeks. 52 weeks in a year. All right, and then 3 years, right? 3 years. So if it's weekly payments, 52 weeks in a year, 3 years, 52 times 3. 52 times 3 is 156 payments. 156 payments, so that's going to be our N value. Okay, N is the number of payments. I is going to be the interest rate, 0.05, divided by the number of payments per period. So that's 52. Divided by 52. So that's going to be, that's the one I didn't do. I didn't do 0.05 divided, so I'm just going to leave it as 0.05 divided by 52. All right, so let's do our formula here. AF equals recurring payment of 100, weekly payment of 100, times, okay, we got 1 plus 0.05 divided by 52, and that gets raised to the 156 minus 1. That 156 is the N, just following the formula, divided by that 0.05 over 52. And divide that out. Okay? So AF is going to equal $16,822.05. All right? So that is our first question. Or that's actually the second question. That's the future value. Remember, future value is A sub F. And then the interest earned is, well, figure out how much you actually paid. 100 a week, right? 100 a week for 156 payments. So 156 payments times $100 a week. That's going to be $15,600. So if you actually paid $15,600, that's what you actually put in, 100 a week for 156 weeks. That's $15,600. The actual amount we have is $16,822. So we earned the difference between those. That extra $1,800 or whatever, that's how much we earned. So let's subtract the amount we actually put in, and we get $1,222.05. That was the interest earned. All right, and again, this is going to take some practice and getting used to in order to fully understand this. But we're going to bring this in with some substance into class. All right, so now loan payments is, so you borrow money and you have to pay it back. How much you're going to have to pay back? We have this formula here that will do that for us. That's called an amortization. Amortization is the process of decreasing the amount owed on a loan over time, which decreases the amount of interest owed over time as well. So the more you pay, you're paying off some of the balance. You're paying off interest at the same time. Every time you make a payment, you're paying off some interest. You're paying off some of the final balance, but you're decreasing the amount owed on a loan every time you make that R payment. Okay, and AP is the total amount of the loan. So let's see how these work. We'll do two of these here. A college student wants to buy a car and can afford to pay $200 per month. That's what they can afford to pay. So that's going to be the payment. It's all they can afford. If she plans to take out a loan at 6% interest per year with a recurring payment of $200 per month for 4 years, what price car can she buy? So what's the total amount of the loan possible? The most she can possibly. So she's willing to go $200 a month, and that's it. And we're going to find out the most she can afford. So it's a realistic thing here. You're going to college, or you're whatever. You're going to be a senior, and you're going to buy a car, and you know you can afford $200 a month based on how much money you make. You could use this formula to figure out what's the total cost of the car that you can afford, the total amount of the loan. If it was 6% interest, you would just change the interest rate at that. All right, so let's do that. A sub P is the total amount there. The recurring payment is going to be $200. So then we have, it works out to be 1 minus, and the reason why is just kind of confusing, so we're not going to really get into that. 1 plus I. Okay, now I is going to be the interest rate per payment period. So in this case, I is going to be 0.05. Oh, sorry. 0.06, and then divide by 12. Okay, because it's monthly payments. So 0.06 divided by 12 is 0.005. 0.005, and that's raised to the negative n, so that's negative 48. N is 48 because it's 4 years And then, of course, monthly payments. So if you pay for 4 years every month, 4 times 12, there's going to be 48 total payments you have to make. So raised to the negative 48 over that 0.005. All right? So there you go. You got to just type that in your calculator, and we'll get it down to $8,516.06. So if it's a 6% interest, and you want to pay it off in 4 years at $200 a month, the most you could afford is $8,516 for a car. Now, that's the total part. That's the total of the loan. So that's got to include all your taxes and all your fees. Example 4 kind of gets into that. Benji's qualified for a first-time buyer financing, which is 60-month loan. So now Benji's going to do 5 years. 60 months is 5 years. With no down payment at an interest rate of 4%. He got a lower percent, which is nice. He must pay sales tax and licensing and other fees. So there's tax and fees. The tax is 6%, and the fees are 2% of the selling price. He decides to buy $12,000 truck. So he already knows my truck's $12,000. But when you buy a $12,000 truck, it's not just $12,000, it's $12,000 plus tax plus fees. And 6% of $12,000 is not like 50 cents, okay? So you got to figure that out first. That's what we're going to do here. How much money will Benji have to borrow? Total borrow would be the money, the $12,000 plus the taxes plus the fees. So he's going to have to borrow $12,000 plus tax plus fees. Got it? So we understand what we're doing here. $12,000 plus $12,000, not $1,200. Not going to get much of a car for $1,200. $12,000 plus tax plus fees. All right. So what's the tax? Well, $12,000, 6%, so that's 0.06. We could figure out the tax that way, and that's $720. $720 just in tax, and that's on a $12,000 truck. New trucks cost you $40,000, $50,000. Think about that. How much the tax would be, right? $12,000, and now 2%, 0.02. That's the fees, licensing, and you got to pay all these fees when you buy a car. That's $240. So that's $960 total. See that? So $960 in taxes and fees. So we're going to add that to our $12,000. So $12,960 is the total amount borrowed. That's the amount we're going to finance. So we're going to figure out what our monthly payment is going to be. So this is figuring out a monthly payment. Sorry about drawing on that. I'm still not used to this pen here. So we know our total amount, that's the amount at the end, is going to be $12,960. And what we're actually doing in this problem is we're finding the R value because we're finding the monthly payment. So we're going to use our formula, 1 minus 1 plus 0.04 divided by 12, because obviously 0.04 is the interest rate, and then of course monthly payments. And that's raised to the negative N is 60 because there are 60 periods total, and we divide by that 0.04 over 12, that 0.04 over 12, okay? So that's our setup there. So that's going to be 12,960 equals R times, if you clean this up, it's 1 minus 1.03 repeating. I did this ahead of time, to the negative 60. It comes out to be 0.03 repeating. When you divide that 0.04 divided by 12, it's 0.03 repeating. So that's 12,960 equals, now throw this in the calculator, you get 54.299. Of course, that's times R. So now we have 12,960 equals 54.299 R. So just to find R, we just divide that out, 54.299. I really can't write on this thing. All right, and R, our monthly payment, is $238.68. So Benji, if he wants to buy a $12,000 truck and he wants to pay it off in 5 years, he's going to have to pay $238 a month. He's got to make sure he can afford $238.68 per month. I will see you in class tomorrow to work on our loan payments and our amortization and our annuities and all this financial math. See you then.